All right, so example 2 now. Again, with this part, if you want to like write it down, pause the video, and then work it out yourself, and then try to come back and see what I do to try to match yourself up, do that. That way you're checking yourself and you're seeing if you're going on the right track. And you just might be going on the right track and you just don't realize it. All right. So with that, again, pause if you want to. If not, just keep watching with me. All right, so with this part, let's go here and we're talking about cosine squared minus sine squared equals 1 minus 2 sine squared x. Now, for me, this side here is still the more complicated side. So I'm going to work on this side over here to get to equal this side. But again, if you just feel like you want to work on this side and then get that, that's fine too. Like you can work on either side of the equation, and as long as you can get both sides to equal each other at the end, you're good. That's all you got to do. All right, so let's take a look at it. Move this off to the side. So we're working at this side. All right, now the big part about this is we have something that looks like a trig identity right here. But remember the trig identity that we're looking for, we should be having for cosine squareds and sine squareds should look like this. So that's our Pythagorean identity. But this is sine plus cosine. That is cosine minus sine. So that means we have to use that identity right there for somehow to get the sides to equal each other. And when I look at that, I immediately look at the right side and say, okay, well, I have to have two sines. So in other words, sine squared x and a sine squared x to give me 2 sine squared x. So in other words, right here, if I have a negative sine squared x minus sine squared x, that means that will be a negative 2 sine squared x. So I'm thinking, okay, well, if I have to have two negative sine squared x's, that means I need to do something over here to get rid of the cosine so that we have another sine squared x there. So the only way to do that is if we manipulate it, the trig identity. Manipulate this. So we can get, we can have 2 sine squares. Right? So if we manipulate it, that means we can move the sine squared over to equal cosine. So if we do that, let me write this in green. And again, it's okay to manipulate it as long as you do it correctly. And these are proven identities, so you can manipulate those. Okay, so here, instead of us writing cosine squared x here, we can actually put the 1 minus sine squared x and hopefully have the two sine squared x's that we need for the problem. So instead of us doing this, come in here and we're switching it over to this. And hey, look at that! We have 2 sine squared x's that are negative. And doesn't that equal that right there? Yeah. Yeah. So it's understood 1 in both of the sine squareds. So if we were to combine those, 1, negative 1, and a negative 1, we have negative 2 sine squared x. And isn't that the answer right there? Look at God. Look at God. Look at God. So move all this down here. And again, we're trying to get you to think in a way that you've never thought before. So you're looking at using all the stuff you've learned from your math classes to simplify things down and to work things apart, separate things and to simplify things to do this part. And then we're just adding on our identities in there to help you a little bit, to have a little bit more tools to use to simplify things down. So here we have verified that they are equal to each other and that this is our trig identity using our Pythagorean identity right here. And knowing that if we have 2 sine squared x's here, that means we would have to do something here to get 2 sine squared x's. And we did. And again, if this part confused you a little bit, pause it, call me over, ask questions, ask questions, ask questions. It's okay to ask questions. Questions are okay. They're good.